If you've ever had to work with data, you absolutely know the pain of duplicate entries. Well, today we're diving into one of Python's most powerful and, I think, elegant solutions for that exact problem: sets. We've all been there, right? You get a column of data, and it is just a complete mess. The same names, the same categories, the same IDs, repeating over and over again. It can turn a simple analysis into a total headache. But what if I told you there's a secret weapon built right into Python just for this? Seriously. When all you care about are the unique values, sets are about to become your absolute best friend. So, let's get into it. What exactly is a set? It's one of Python's built-in data structures, and it's all defined by one single, incredibly powerful characteristic. Okay, so a set is just a collection of items, but it has one golden rule: no duplicates allowed, period. It's also unordered, which means the items don't have a specific index or position. And because it automatically enforces uniqueness, it is incredibly fast for checking if an item exists in a collection. That's a huge performance boost over lists, especially when you're dealing with massive data sets. This visual just nails the difference. On the left, you've got a list. It's totally fine with holding duplicate items, you see the multiple squares and circles, but the moment you convert that into a set, like you see on the right, poof, all the duplicates are instantly gone, leaving you with just one of each unique shape. And the code to do this is ridiculously simple. You just take your list, in this case we're calling it nums, and you pass it to the set function. That is literally all it takes. Python does all the heavy lifting for you, giving you back a brand new set with only the unique items. Of course, sets aren't just static. You can easily add and remove elements once you've made one. So let's take a quick look at the most common ways to do that. So here are the 4 big ones. Add is simple. It just adds a new element. Pop removes a random element. You don't know which one you're going to get. But I want you to pay close attention to the next 2. Discard and remove. They both get rid of a specific item, but they handle mistakes in a way that is critically different. And here's the key takeaway. If you try to remove an item that isn't actually in the set, your whole program is going to crash with an error. But if you use discard and the item isn't there, no problem. It just does nothing and moves on. For data cleaning scripts, trust me, discard is almost always the safer, more robust choice. Okay, now we get to the really fun part. This is where sets go from being a useful tool to a data science superpower: operations. This is how you can compare and combine different sets of data with just incredible efficiency. First up is the union. The easiest way to think about this is just combining 2 collections into one big one. The final set will have every unique item that was in either of the original sets. Here's a great way to think about it. Imagine you're making a master list of all the skills found on 2 different resumes. If both candidates list Python, it's only going to show up once on your final combined list of skills. That's a union. Next up, we have the intersection. This is kind of the opposite of a union. It looks at 2 sets and finds only the items that show up in both of them. And if we stick with our job analogy, an intersection is like finding the skills that are required by both job descriptions. It's perfect for finding that common ground between 2 different data sets. And finally, we have the difference. This operation is all about finding what's unique to the first set when you compare it against the second one. And, the order here really matters. This just says it all, doesn't it? If set A is your list of skills and set B is the job's requirements, the difference, A minus B, shows you all the great skills you have that aren't even on the job description. It's fantastic for spotting what makes one dataset different from another. All right, theory is great, but let's actually put this into practice. We're going to walk through a super quick mini project where we clean up a messy column right from a dataset step by step. So here's our before state. Just imagine this is a column in a spreadsheet listing out states. As you can see, Kerala and Tamil Nadu are repeated a bunch of times. All we want is a simple report of which unique states are actually in our data. And here's the magic trick. One single, super readable line of code. We take that entire messy list, which we've called categories, and we just wrap it in the set function. And voila! There's our result, a perfectly clean collection that has only the unique states from our original data. All that noise, all that repetition, it's just gone. Just like that. And if we ask for the length of that new set, we get our final answer. There are exactly 3 unique categories in our dataset. We went from a messy, long list to a precise, actionable number in one single step. So as you can see, sets are so much more than just a programming concept. They're a direct, powerful tool for cleaning and understanding your data. And now you have that tool. The only question is, what messy data are you going to clean up first?